Hello, my lovelies. It's Susanna, and today I want to show you how to solve this problem. A farmer goes to a market and buys goats, rabbits, and ducks. Altogether, he pays $100 for 100 animals. One goat costs $10, one rabbit costs $3, and two ducks cost $1. How many goats, rabbits, and ducks does he buy? Okay, so this is about a farmer who buys 100 animals and he pays $100 in total for that. Each animal has a different price and we have to figure out how many goats, rabbits, and ducks he buys. Okay, so maybe we call the number of goats that he buys G, the number of rabbits that he buys R, and the number of ducks that he buys D. Because we know that it has to be 100 animals in total that he buys, we know that the number of goats, so G, plus the number of rabbits, R, plus the number of ducks, is our D, has to be equal to 100. So we have a first equation, three variables, so let's find another equation. But we get more information about the amount he pays. So he spends $100, and these are the prices for the animals. So in total, he spends $100, and if he buys G goats, and each goat costs $10, then he spends 10 times G on the goats. So 10G goes in here. Then he gets R rabbits. Each rabbit costs $3. So the amount he spends on rabbits is 3 times R. And then he also buys ducks. Here we have to be careful. 2 ducks cost $1, so 1 duck costs half of this, so it's 50 cents. So we add 0.5 ducks, or 0.5 cents for each duck in here, and then we get in total $100. That is actually all the information we have. So we have 2 equations, but 3 variables, which is not great to begin with, but maybe we can find the solution anyway. So let's first get rid of one of the variables. We have G in here, R in here, D in here. Same here, we have G, R, D. Here we have 0.5 D. I'm not a fan of decimal numbers, so maybe we get rid of D first. To get rid of D, we have to make sure that we have the same amount of D's here and here, which is not yet the case, but if we multiply this equation here by 2, then we have 0.5D times 2, which equals 1D, same amount here. And then we can just subtract both equations, and then D will disappear. So that's the plan. Let's do this. We start here. 10G times 2 equals 20G minus 1G gives us 19G. Then R next. 3R times 2 equals 6R minus 1R equals 5R. The D will disappear because 0.5D times 2 equals 1D minus 1D, so this cancels out. That's what we wanted. And on the other side, we have 100 times 2, which equals 200 minus 100, that is 100. Okay, so now we only have one equation with 2 variables. Do we know something about G and R? I mean, he buys animals, so G is a number starting either from 1 or a 2 or a 3 and so on. But the question is there a limit for the amount of goats he's going to buy? I mean, each goat costs $10. He only spends $100 in total, so he cannot buy so many goats. Even if he bought 10 goats, he would have $100 already, so he has to buy less than 10 goats. And what about the rabbits? Each rabbit costs $3. So, I mean, he buys goats, rabbits, and ducks. So, if he just bought one goat, because he has to buy at least one goat, and spends $10 on a goat, then of the $100, he would only have $90 for the rabbits and the ducks. So the rabbits, $90, and each rabbit is $3. He can only buy 30 of the rabbits, so he has to buy less than 30 rabbits so that he doesn't exceed the $100. So we keep this in mind that we have these limits for G and R. Maybe they help us somewhere. We take our equation and let's see if we can figure out G and R. Maybe we solve this equation now for either G or for R. Let's solve it for R. So let's get rid of the 19G here by subtracting it on both sides of the equation so that this cancels out here and only the 5R are left. And on the other side, we have the 100 minus the 19G. To solve for R, we have to get rid of the 5 here, so let's divide both sides of the equation by 5 so that this cancels out and only the R is left. And here, maybe we can write this one big fraction as two separate fractions. So we start by taking the 100 over 5 first, and then we subtract the 19G over 5 here as a second fraction. 100 over 5 is just 20, so we have a nice number here. But here we have this beautiful fraction still. In total, all of this has to be the amount of rabbits that he buys. And the amount of rabbits is either 1 or 2 or 3 and so on. It has to be a whole number. He cannot buy half a rabbit. Not alive. So we know that this number here has to be a whole number in total. The 20 is a whole number. This here is a fraction, and depending on the G, this could be a whole number or not. When is this fraction a whole number? When does this fraction disappear? If G is a multiple of 5. So G could be 5 itself, or 10, or 15, 20, and so on. So let's say G was 5. Let's insert it here to see what happens if it was 5. Then this cancels out, and we get a whole number as a result. So the question is G 5 or 10 or 15? What is it? Well, we did some work already. We know that G is less than 10. So all these numbers are not possible for G. G has to be 5. So we just found our G. He buys 5 goats. And if we know that it is 5 goats, we can insert the 5 here. This cancels out. And for our rabbits, we get 20 minus 19, which equals 1. He buys 1 rabbit, 5 goats. And how many ducks then? Well, this is 6 animals. He buys 100 animals in total, so then he has to buy 94 ducks so that he has 100 animals in total. I'm curious how you solve this problem, so please let me know in the comments. I wish you a wonderful day, and I hope to see you in one of my next videos. Take care!